Hello students, let us understand theory of equations. Earlier we have learned quadratic equations, ax square plus bx plus c of second degree. We know sum of the roots is minus b by a, product of the roots is c by a, and we are going to take this to a higher degree level, x to the 4, x to the 5, x to the 6. A generalized term is x to the power of n, nth degree. So we'll understand how the roots are behaving and how we can have correlate between coefficients and roots and understand our theory of equations. Okay, let us proceed. So this is chapter 4 of 2A lesson, class 12th, theory of equations. Before going through this process, we will understand a simple division. Suppose f of x is there. It is to be divided by x minus 2. So how we divide? We know this division process earlier. So we put x is equal to 2 and we write the coefficients of f of x. So first we put 0, 1, 2 ones are 2. Then we add these two. So minus 3 into 2 is minus 6. Then we add 1 into 2 is 2. Then we add minus 15 into 2 is minus 30, minus 90. So this equation f of x, if this is g of x, x cubed minus 3x square plus x minus 15. F of x is, this is f of x. So what is f of 2? Because I am dividing it by 2. What is f of 2? If I substitute 2 here, 2 to the power of 4 is 16, minus 5 into 2 cube, plus 7 into 4, minus 17 into 2, plus 11. This is around minus 19. This is the remainder. This is the remainder. So here we have seen here that f of x is equal to g of x. F of x is equal to g of x into x minus a plus f of a. F of a is nothing but the remainder. This is f of a minus 19. We have seen f of a is 2 here. We have seen it is minus 19, remainder. So this is simple, our division. Quotient into divisor plus remainder is equal to dividend. So the remainder here we found is equal to f of a. So if f of a is 0, suppose if f of a is 0, that means what? The x minus 2 is a factor of this. X minus 2 is a factor of f of x because remainder is 0. So we'll say gx also is a factor and x minus a is also a factor if remainder is 0. So general term is f of x is equal to g of x into x minus a plus f of a. This is also applicable for our quadratic or above equations. This is a general term. Let us say f of x is equal to a0 x to the power of n, x to the power of n minus 1 up to an. This is a generalized term. Here we have taken only up to x to the power of 4. Here it is a generalized term. When I am putting generalized term, I am dividing with x minus a. So I put x is equal to a. So I get different additions. Here I got these additions. Here also. First is a0. a0 into a is a into a0. a1 plus a into a0. Let this call as b1. So this is a into b1. a2 plus ab1. Similarly, a3 plus ab2. Like that, an minus 1, abn minus 2. So what is the last term left out is an plus abn minus 1. So this an plus abn minus 1 is the last term. So now I am putting g of x. This is b0, b1, b3 up to bn minus 1 is g of x. And this is the remainder. Whatever balance is the remainder. Suppose g of x is equal to g of x into x minus a. This is g of x. This is x minus a. So I am multiplying these two. So x into g of x minus a into g of x. So x into b0, b1, bn minus 1 minus a into b0, b1, b minus 1. If you take the common terms, here x into x to the power of n minus 1 is x. X to the power of n into b0. But b0 is equal to a0. B0 is equal to A0. Similarly, B1 minus A B0 into x to the power of n minus 1. X into x to the power of n minus 2 is x to the power of n minus 1. Here also minus A into x to the power of n minus 1, A B0. So B1 minus A B0. What is B1 minus A B0? B1 minus AB0 is nothing but is A0 is B0. B1 minus AB0 is A1. So this total terms becomes f of x minus the last terms. Last terms are an and abn minus 1. These two are the last terms. So this is nothing but f of a. But here we know f of x minus, if we put x is a, then what is left term is becoming x minus a is 0. So this term is becoming 0. So if this is 0, that means f of a is equal to an plus abn minus 1. This is the remainder of this entire process. This is a generalized process and which we have understood simply through a normal equation of x to the power of 4. So if it is a factor, we know f of a is 0. If I substitute that factor here, it becomes 0. So remainder theorem is applicable to polynomials. Let us see another way of doing this. F of x, instead of like this, a0x, it can be written also a into x minus 1 into x minus 2 up to x in x minus xn. The nth degree is having n roots. So f of x is equal to a into x minus x1 into q of x, which is having n minus 1 degree. So this is one factor we are taking out. If I take two factors, I have n minus 2 degree. Like that, this continues. So this we extend the fundamental theory of algebra that a polynomial has at least one root. C means what? Complex number. C is complex, a plus ib, complex number. So n degree has n roots. N degree has maximum at most n roots. Out of which some may be repetitive, some may not be repetitive, but they have total n roots. Because if I multiply with n times only, I will get x to the power of n. Suppose if I multiply with n times, what I am getting x into x into x into x to the power of n is n degree polynomial. So out of this slide, what we understood? We understood that a remainder theorem, divider is equal to quotient into dividend plus remainder, applicable for the polynomials also. And also we understood f of a is the remainder of the system. And if f of a is 0, then x minus a is the factor of the system, or x is a is a root of the system. And if n degree is having n roots. Okay, this can be in complex numbers. What is a complex number? There is x-axis and y-axis. Along the x-axis, we have real number. But if we go into the y-axis also, x plus iy, we have a complex number. Let us go to next. So let us see a generalized correlation between coefficients and roots. Suppose there is a 4 degree polynomial, a x to 4 bx cubed 6 squared dx plus a. So now there are 4 roots here. 4th degree means x minus alpha and x minus beta and x minus gamma and x minus delta. 4 roots. Okay. Now sum of the roots is minus b by a. First term is minus b by a, then c by a, then minus d by a, then e by a. Alternatively, the minus plus varies. So what is e by a? E by a is the product of the roots. So alpha, beta, gamma, delta is e by a. What is 2 roots taken together? Sum of product of 2 roots taken together. Alpha, beta, beta, gamma, gamma, delta, alpha, gamma, all the combinations. 4c2. What is 4c2? 1, 2, 3, 4, 5, 6. 4 into 3 by 2. So 6 terms will come into 4c2. So that is c by a. This is plus 1. This is minus b by a. This is plus c by a. So similarly, 3 products taken together. Alpha, beta, 4c3, 4C3 is 4C1. That is 4 items will come into system. These are the 3 combinations out of 4 roots. That is minus D by A. This is minus D by A. So what you get? Minus B by A, plus C by A, minus D by A, and plus E by A. So if you see in the general term, same thing let us understand for general terms. This is the equation. So this equation can be written as x3 minus x1 into x minus x2 into x minus x3 up to x minus xn. When I multiply this with f of x, this is f of x. So when I am expanding this, when I am expanding this, what I am getting? X to the power of n I am getting. Then x to the power of n minus 1 into sigma xi, x1 plus x2 plus x3 up to xn into x to the power of n minus 1. This is minus. Again plus, because minus 1 whole to the power of 1. Here plus. See, basically what's happening? Minus x1 into x to the power of n. Minus x2 into x to the power of n minus 1. X to the power of n minus 1. Minus x3 into x to the power of n minus 1. Minus xn into x to the power of n minus 1. So sigma xi into x to the power of n minus 1 minus. So this minus of each are getting added. So for the second term, we get x to the power of n minus 2, x1, x2 into x to the power of n minus 2. So minus into minus plus. Again, this becomes minus. This becomes minus. Like that it goes. This is minus because 3 terms are there. Minus into minus into minus. This becomes minus. X to the power of n minus 3. So like that alternately we get sum of the terms is minus b by a. Then 2 terms taken together is plus c by a. 3 terms taken together is minus d by a. 4 terms taken together is e by a. Like that, this alternate plus minus varies. So last one is x1 to xn. This is the product of the terms, is the numerical value of the equation, which is an. Which is an. Sigma xi x to the power of n minus 2 is a2. Sigma xi x to the power of n minus 1 is a1. So we will say the sum is minus b by a. Sum is minus b by a plus c by a minus d by a plus e by a. Like that it goes on. Like that it. Last one is minus 1 whole to the power of n into an by a. So minus 1 whole to the power of n into an by a0 is the product of the roots. So from this generalized form, we will get to a 4 degree. So the concept is clear. Why minus plus are coming? Because of number of multiplication. If 1 multiplication, minus. If 2 multiplications, plus. If 3 multiplications, minus. 4 multiplications, plus. Because minus into minus into minus into minus. Yes, plus. Okay. Based on the x1 value. So based on understanding, let us do some problems for the test. What are the equations having roots 1, 3, minus 1? So we can simply write x minus 1 into x plus 1 into x minus 3. We can directly multiply this and get this answer. Otherwise, if you see what is the sum of the roots, 1 minus 1, 0, 3. So minus 3x square minus b by a. What is the product of roots? 1 into 1 is minus 3. So minus c by minus d by a. So plus 3. What is this coefficient? 1 into 3 is 3. 3 into minus 1, minus 3 get cancelled. So 1 into minus 1 is minus 1. So minus 6. So we can divide this coefficient by using the formula, or we can straight away multiply also. Whichever is easier, we should approach. Since it is a small one, we have taken a multiplication. Now you see here, this one. It is having 4 roots. Plus r minus 1 plus r minus 2a, 4, 2. Now we have to find out the equation. What is the sum of the roots? When I am adding all these, I am getting 8. What is the product of the roots? When I am multiplying, 1 square minus 4i square. Minus 4i square is plus 4. So 5 into 4 into 2, that is 40. So 2 together, taken each together, is 4 into 3 by 2. That is total 4c2. Out of 4, I have to take 2 together. So 6 will come. So I am adding 1 into 2 plus 2 plus 2 plus 2. There are 6 multiplications. 6 combinations will come. So AB, AC, AD, BC, BD, CD. Like that, 6 combinations will come. When I'm adding all these things, I'm getting 25. So 3 together, sigma xij, 4c3, 4 items will come. ABC plus ACD plus BCD plus BAD. 3 will come. 4 will come. So when I'm substituting the respective roots here, I'm getting this. So now we know x to the power of 4 minus, what is the sum of the roots? 8. So minus x, 8 is cubed. What is the two products each? 25 plus 25x square. This is 46 minus 46x. And what is the product of the roots? Is 40 plus 40 is equal to 0. This is the equation. Or we can get by multiplying all the 4 root form of the equation also. Okay. Now let us understand. 3 roots are there. 1 minus 2 are the roots of this. Find A to be found out. Very simple. So I am taking 2 together. 2 together is equal to minus B by A plus C by A. C by A is A itself. So what is the two products? 1 into minus 2 plus 1 into 3 plus minus 2 into 3. That is minus 5. C is A is equal to minus 5. See the another problem. X cubed minus 2x square plus 3x minus 4 is equal to 0 is a third degree polynomial. We want to find out sigma A square B square. Sigma AB into A plus B if A, B, C are the roots of this equation. So sigma A square B square. That means what? A square B square plus B square C square plus C square A square. It is like A square plus B square plus C square. It is nothing but A plus B plus C whole square minus 2 into AB plus BC plus CA. So when I'm putting this, if I'm taking out ABC here, A plus B plus C. I know this is a product of 2 terms. This is a ABC product of all roots. This is sum of the roots. So if I substitute from the equation, AB plus BC plus CA is minus B by A. This is C by A, 3. So this is 3 square. What is ABC? Is minus 4. So minus 2 into ABC is minus B by A plus C by A minus D by A. So this is plus 4. So 2 into 4 into A plus B plus C is minus half minus 2 is 2. So when I substitute, I'm getting minus 7. So here, what is more important in this? This is simple algebra equation we should understand. What is A square plus B square plus C square? A plus B plus C whole square minus 2 into AB plus BC plus CA. So this formula, we should have the knowledge of this formula so that our purpose is to convert whatever is given in the form of either A plus B plus C or ABC or AB plus BC plus CA. That is the purpose. So now let us see the second one, AB into A plus B. So when I expand the sigma, AB into A plus B plus BC into B plus C plus CA into C plus C. So when I'm putting C here. So ABC into A plus B plus C by C. ABC into B plus C by A. ABC into C plus A by B. So I know A plus B is what? A plus B plus C is 2. So A plus B is 2 minus C. 2 minus C. 2 minus B. So when I am taking out A by A is 1, C by C is 1, B by B is 1. So minus 4 minus 4 minus 4. 4 into 2, 8 by C plus 8 by A plus 8 by B. So when I simplify this, 1 by A plus 1 by B plus 1 by C is equal to 8 into AB plus BC plus CA by ABC minus this 3 4s are minus 12. So we know these two from the equation. So 8 into 3 by 4. So we are getting minus 6 is the answer. So the signature, the sign is important. What is AB plus BC plus CA? Minus plus 3. So it is plus 3. What is ABC? Minus plus minus. Minus or minus 4 is plus 4. So if it becomes minus 4, the value will be changed. So we should be very careful choosing the sign. Let us say a higher complicated problem. It is numbers are not given. Here it is easy for us. 2x square, 3x, 4. It is easy to manipulate. But here generalized terms are given. Px square, qx plus r. So we have to find various sigmas. Let us understand. So from this, we know if alpha, beta, gamma are the roots, then sum of the roots is minus p. Product of the roots is minus r. And taking 2 together, alpha, beta, beta, gamma, gamma, alpha sum is q. So minus, plus, minus, minus, plus, minus. So based on this, let us understand this. So 1 by alpha beta square is can be taken as 1 by alpha square beta square plus 1 by beta square gamma square 1 by gamma square alpha square. This is sigma. So when I do the LCM, what I am getting here? Alpha beta gamma whole square. This is whole square. Alpha square plus beta square plus gamma square. So this is a square plus b square plus c square. This can be written as a plus b plus c whole square minus 2 into ab plus bc plus c. Now all are in our regular terms. This is sum of the products, sum of the two, and this is the product. So when I substitute the values, I am getting b square minus 2q by r square. Let us say other one, sigma b square plus gamma square by beta gamma. So here to give an expanded form, this is expanded form. So we are using same expanded form. So here again I am taking LCM, alpha, beta, gamma. So we are getting this. So this can be converted into alpha plus beta plus gamma into alpha beta plus beta gamma plus gamma alpha minus 3 alpha beta gamma. See, alpha into this, alpha square beta. You got alpha square beta, alpha into gamma alpha, alpha square gamma. These two terms are covered. And what is left out is alpha beta gamma. Similarly, alpha beta gamma, alpha beta gamma. So 3 alpha beta gamma excess I am reducing. So this my multiplication is becoming this. So we should understand how to convert such an equation into my required form. We know this, we know this, we know this from the equation. So when we substitute, I'm getting PQ minus 3R by R. Let us see another. So this is what has been asked. Please beta plus gamma minus 3 alpha, gamma plus alpha minus 3 beta, alpha plus beta minus 3. We know alpha plus beta plus gamma is equal to P minus P. So same will substitute here. Beta plus gamma is minus P minus alpha. So minus P minus 4 alpha. Minus P minus 4 beta minus P minus 4 gamma. When I simplify and take out minus here, this is the form. So I am multiplying the 3. When I am multiplying the 3, I am getting in sum of two roots, product of the roots. So when I substitute the values, I'm getting 3p cubed minus 16p cubed plus 64r is the equation. So how I have proceeded? I have simplified the given equation in terms of continuously converting into PQR. Continuously converting into PQR or converting into PQR formats. So let us see the last one, sigma a cubed b cubed. This is sigma alpha cubed beta cubed. Instead of alpha cubed beta cubed, I have written as a cubed b cubed. So this is a cubed plus b cubed plus c cubed. What is the formula for a plus b plus c whole cube? A cube plus b cube plus c cube plus 3 into a plus b into b plus c into c plus a. So here what is asked? A cube plus b cube plus c cube is asked. So this will go to other term. So this becomes ab plus bc plus ca whole cube minus 3 into a plus b plus b plus c plus c plus a. Here c means it is given two terms each. Okay, we have taken two terms each. So this ab plus bc plus ca we know from the equation Q cube. So minus 3 into BC plus CA can be written as Q minus AB. This is Q minus BC. This is Q minus, because sum of the two is what? AB plus BC plus CA is Q. Instead of alpha, I have used ABC here for typographical easiness. So Q cubed minus 3 into Q minus AB, Q into B minus AC, Q minus AC is like this now. It has become same. For instead of plus, it is minus. So when I am expanding and converting into ABBCCA format, I can simply substitute Q cubed minus 3 into Q cubed plus Q square into this. What is AB plus BC plus CA? We know AB plus BC plus CA is Q. AB plus BC CA is Q. So this is minus Q. So minus Q cube, Q cube getting cancelled. So when this we are substituting the respective values, having Q cubed minus 3PQR plus 3R square is the answer. So we should be able to converse it by doing more and more practice on such equations. Let us see. This is a third degree polynomial in general terms. Instead of all plus, he has given minus, plus, minus. So sum is plus P, two products is plus Q, all the product is plus R, everything is plus, plus, plus. Find the sum of the cubes of the roots. Simple. What is asking? He is asking A cube plus B cube plus C cube. We know the formula. A plus B plus C whole cube minus 3 into A plus B into B plus C into C plus C. This we know A plus B is what? B minus C. The B plus C is P minus A. C plus A is P minus B. So when I'm expanding it and converting into required form, I'm getting P cube minus 3P cube plus 3R. Okay, now we'll go to another one. If ABC are the roots of this equation, find the equation whose roots are A square plus B square plus C square plus A square. Now, one way is you put in terms of A plus B plus C is 6, AB plus BC plus CA is 11, ABC is 6, and convert into these three roots and apply the form. This is very complicated. In place of that, let us find out the roots itself. From this, what is ABC? What is ABC? See, by seeing itself, I put 1 here. 1 minus 6 plus 11 minus 6. So this is minus 12 plus 12, that is 0. So 1 is a factor. So I am dividing it by 1. So I am getting a quadratic equation. This is minus 3 minus 2. So 2 and 3 are roots. So we can say the ABC are nothing but 1, 2, 3. So what is A square plus B square is 5. What is B square plus C square is 13. What is C square plus A square is 10. So these three, with these three roots, I have to write the equation. So we know x cubed minus sum of the roots is 28 plus two products 5 into 13, 13 into 10 plus 10 into 5 is x minus product of the roots. So this is the required equation. So let us see another problem. We have to prove that A minus B into A minus C is equal to 9. Here also general forms are given 3p. There is no x square here. So that means what? If the three roots A plus B plus C is 0. So because B term is 0 here. A plus B plus C is 0. AB plus BC plus CA is minus 3p. ABC is minus. Okay. This is minus B by A, C by A. C by A is minus 3p. Is minus D by A. Minus D is minus Q. So we got our equations. So this we are expanding. A minus B into A minus C. When I am multiplying A square minus A into B plus C plus BC. What is B plus C? B plus C is nothing but minus A. So minus A into minus A plus A square. So 2A square plus BC. So now I am expanding this sigma. So 2A square plus 2B square plus 2C square minus BC plus CA plus D plus AB. What is BC plus CA plus AB? Is minus 3p. So I put here as minus 3p because it is plus BC plus CA plus CB plus BC plus CA is minus 3. So a square plus b square, again same formula, a plus b plus c whole square minus 2 into ab plus bc plus ca. So a plus b plus c is 0. So ab plus bc plus ca is again minus 3p. When I substituting, I'm getting 9p. Now this is 12p minus 3p is 9. So we will be roaming around these figures. Either you simply expand it and substitute, or you simplify and then expand sigma. Based on our experience, we should be able to decide. Because it has been simplified here. I have done before simplification. So 2a square plus bc. It is more simplified here before sigma. Then I expanded sigma. We can expand in the early stage also. No problem. Now you see the other problem. Sum of two roots is 0. Find the condition. Find the condition. Simple. If ABC are the roots, a plus b is 0. Sum of two roots is 0. That means b is nothing but minus a. So a minus a, c. So that means when sum of the roots a plus b plus c is p. So that means c is p. If I substitute p here, c is a root. Yes. So I can substitute p here. So p cubed minus p cubed get cancelled. So p cube is equal to r. This is the condition. Or we can use other method also, a lengthy method. I'll find out what is product of the roots is r. The root is r. So AB is equal to r by p. So from a plus b and AB, I am finding a minus b. So a minus b is this. I found a and b separately. A and b separately. Now the second one is AB plus BC plus CA is equal to Q. So I am substituted this. So a BC plus CA getting cancelled. So r by p is equal to Q. So PQ is equal to r. This is slightly complicated approach. What is easy approach? Simply put one root you find out, put into the equation, we'll get the condition. Easy. See, we'll do the same thing here. Find the condition. They are in harmonic progression. In third degree, general terms. So let harmonic progression means what? The reverse is in arithmetic progression. Let the roots be 1 by a minus b, 1 by a, 1 by a plus b. So now we have made product of the roots. 1 by a into a square minus d square is equal to minus r. Again, two roots together, ab plus bc plus 3q. This is 3q. So 1 by a into a minus d, 1 by a into a plus d, plus 1 by a square minus d square is 3. When I am simplifying it, what I am getting? These two getting cancelled. And I am using 1 by a into a square minus d square is minus r. So 3q is equal to 3a into minus r. So 3q is equal to a minus q by r. See d getting cancelled. A plus a plus a, 3a by a into a square minus d square. 3a by a into a square minus d square. But a into a square minus d square is minus r. So 3a into minus r is equal to 3q. So I got a here. So what is the root? 1 by a is the root. So let us not put a into this equation because it is a harmonic progression. Root is not a. Root is 1 by a. So once I put root r minus r by q into this equation, I am getting the required condition. 2q cubed is equal to r into 3pq minus r is the required condition. So let us see, one root is double of other. Find the roots. These are the condition between roots. So one root double means I can simply say a, 2a, b. These are the three roots. So I have taken double here. So by using sum of the roots is minus 3 by 2. So I have taken b in this form. Now, product of the roots is 2a square b is, what is the product of the roots? 2a square b is minus 3 by 2. So 2a square, then product of 2 together, 2a square plus 2ab plus ab is equal to minus 8 by 2. So 2a square plus 3ab is minus 8 by 2. When I solve these two, I am getting half 1 and minus 3. This is these two roots. This root is double than this. So these are the 2, 3 equations. So in assumption itself, we should make it easy. If one root is double of other, we need to put another equation here. A, B, C, B is equal to 2A. No, that is complicated. In selecting root itself, you should take A, 2A and B. It's easy for us. Here it is given. We have to solve this equation. So always we use plus or minus 1, 2, 3 by I itself. Suppose I put 1 here. 1 minus 6 is minus 5, plus 13, 8, minus 24, 8 minus around minus 16, plus, so 1 is not a root. Similarly 2, similarly 3. If I substitute 3 here, I am getting 0. That means what? X minus 3 is a factor. So I am dividing this equation and reducing a 4th degree polynomial to a 3rd degree polynomial. You see, remainder automatically becomes 0. This is the remainder, last component. So I am getting 3rd degree polynomial. Again, I find here 3 is a root. So 3 cubed minus 3 cubed getting cancelled. 12 minus 12, 0. So again, 3 is a root. So when I am getting a quadratic, here again 0 is the remainder. So x square minus 4 is equal to 0. That means x is equal to plus or minus 2i. So what are the total roots? 3, 3 plus or minus 2i are the roots. So whenever such a bigger equation is given, we check for plus or minus 1, 2, 3. For the to find initial factor. This is initial factor. Subsequently, my work is this. Let us see. Here, given that the product of two roots is 6. So, by 1, 2, 3, plus or minus. So, I found minus 2 is a factor. Minus 2 is a factor. So, I am dividing it by minus 2. We know the division method. So, the coefficients are taken 1, 1, minus 16, 4, 48. So, when I do division, I am getting remainder 0 and I got a 3rd degree polynomial. So, here we have seen minus 2, 6, product of two roots is 6. This is minus 2. Minus 2 into minus 3 is 6. But minus 3 is not a root of this. So that means this is not part of this product of two roots. So let us assume for this, for a by 6, a, 6 by a, b. Here product of these two roots is 6. Because this is not part of the product of two roots. So when with this, I solve the quadratic of this equation, sum and products. When I'm solving, I'm getting a 2 or 3. 2 or 3 or 3 or 2 because the product is 6. 2 into 3 or 3 into 2. So the equation is 2, 3 minus 4 minus 2. Otherwise, if I substitute 1, 2, 3 plus or minus, I'm getting all here. If I substitute plus 2 is also a root. Plus 3 is also a root. Minus 2 is also a root. So only minus 4 I have to go for division method. So first I have to divide with minus 2, then I have to divide this with plus 2, then I have to divide this with plus 3, then automatically I get x plus 4 is equal to 0. So x plus is equal to minus 4. I can go for all 4 divisions also. Because my trial and error is 1, 2, 3. Okay. Now let us see this problem. Sum of two roots is 0. So we put this into selecting the roots a, minus a, b, c. These are the sum of the two roots. So when I am adding, so b plus c is 1 by 4. So now I have two equations with the two roots as a minus a and two roots as b plus c. So let the two factor equation x square, a plus b is 0, a minus a is 0, plus p1. P1 is a unit term, a numeral term. X square minus this one, b plus c is 1. bc we do not know. bc I am putting as p2. ab I do not know. A square, ab is minus a square. I do not know. So I put as p1. So when I multiplied these two equations, we are getting a 4th degree polynomial and equating the terms of x same powers. You see here, when I equate 2p1 is equal to minus 6. So where is this 2p1 I'm getting when I'm expanding? P1 2x square into p2 plus p1. p2 plus p1. So here you see 8 into p1 by 4 is x coefficient. So for 2 are 8. So 2p1 is x coefficient. What is x coefficient here? Plus 6. Here it is minus 2p1. So minus 2p1 is plus 6 or p1 is minus 3. When you get p1 is minus 3, that will get p2. That will get p2. So we can solve this by minus. So now we have two equations. X square plus p1 is one equation, and x square minus 1 by 4x plus p2 is second equation. So when I take the remove the fractions, I'm getting both equations. So from the equations we get the roots. What are the roots here? X square minus 3 is 0. So x is equal to plus or minus root 3. Here also x is equal to 3 by 4 and minus 1 by 2. So what are the total roots? Minus 1 by 2, 3 by 4 plus or minus root. Always you remember, if the coefficients are all real numbers, so this third root 3 will come in both plus and minus. Because when I do sum of the roots, these two get cancelled, I'll get a real coefficient. I'll get a fraction quotient. I did not go for a third irrational number. It's a rational number. So these two get cancelled. Okay, we'll go to the other one. So this is general coefficients are given. Ax power 4, bx cubed, 6a squared, dx plus c has two pairs of equal. Two pairs of equal roots. Let them be ppqq. So I am taking two equations. X square, sum of the roots into x plus product of the roots whole square. Because both equations are same. I have taken PQ as one equation, PQ as other equation. So I am multiplying two quadratic, it will become x to the power of 4. So A is taken up outside. The coefficient of linear coefficient A is taken outside. So when I do the square of this, I am getting this is a square. I know P plus Q is minus 2B by A and PQ is E by A, root of E by A. Because E by is a product, all product is P square Q square is E by A. So it is plus or minus, minus, plus, minus, plus, plus E by A. So I have substituted this to integrate. Then I am expanded. This is a total expansion of the whole square plus B square plus C square plus 2AB plus 2BC plus 2CA. So when I simplified it, so when I expanded this A plus B plus C whole square and rearrange the terms of x square coefficient, x coefficient, x cubed coefficient, and numerical term. So when I'm equating these terms with the original f of x, I'm getting one equation is EB square is AD square. That means E by A is equal to D square by B square. Root of E by A is D by B. When I substitute here, root of E by A is D by B, I'm getting 4B square by A plus 2A into D by B. A into D by B. 2 get cancelled, 3C. So this AB will go here, 3ABC is equal to 2B cube plus A square D. The LCM is AB. This is multiplied by B, B cube. This is multiplied by A square D. So AB will go to other side. So we should be able to, how we have proceeded this problem? Two roots are equal. And we made two equations. Same equation with P plus Q as a root. So this is how, what is this one? This one is A into x minus P into x minus P into x minus Q into x minus Q. So that is that x minus p into x minus q whole square. So this is the equation whole square. And we compare the terms. So now it has three roots. The question is, this equation has three common same roots. So when same root 3 means what? F dash x, f double dash x, and fx the same root. So I'm putting f dash x. So when I do differentiation, 5x to the power of 4 minus 15x square plus 10x minus 1. 1 is 0. So again f double dash x. 20x cubed minus 20, 15 to the 30x plus 10. So in all these three, we found that one as its root. Here if you substitute 1, 20 plus 10 minus 30 is 0. Here also if you substitute 1, 5 minus 15 plus 10 is 0. Substitute 1 here. 1 minus 5 plus 5 minus 1 is 0. This of course is a reciprocal equation. We'll come back to that concept later, but now it is 0. So 1 is common root for all the three. So how we say is a repetitive root? Here we do f dash x and f double dash x. Here also you see, here there is no repetitive root. There is no repetitive root here. Here also there is no repetitive root. Whenever repetitive root is there, one anyway. So this is a repetitive root. X is 3 is dividing x power 4 to x cube. Again x is 3 is dividing x cube to x square. So it is f dash x. Basically x is f dash x. 4x cubed minus 18x square plus 26x minus 24 will also have 3 as root. Okay. So same root means f dash x, f double dash x also can be checked. Let us see one more problem. Find the repeated roots of this. Repeated roots of this. I am putting x as 1, 2, 3. This is a trial and method. First put x is 1. It is 0. Putting x is 2. Then also it is 0. So now I am putting so here. So 1 and 2 are its roots. 1 and 2 are its roots. Now we have done f dash x. Here the f dash x, x is 2 or for x is 2 or f dash x is 0. That means 1, 1, 2, 2 are repeat roots. F dash x also for both for 1 and 2 it is 0. That means 1 is a repeated root and 2 is also a repeated root. Now we have 4 roots already have come. 1, 1, 2, 2. Because it's polynomial of 5th degree, so I should get one more root. In the trial and error, I am finding minus 3 is also a root. Otherwise, what we have to do? We have to divide this equation by x is equal to 1 4 times. X is equal to and x is equal to 2. X is equal to 1 2 times. X is equal to 2 times. We have to divide this so that when I get x plus 3 is 0 in the last, so x is equal to minus 3. So this way also we can do. All factors are within 1, 2, 3 plus or minus. So I can straight away write. Okay. Let us continue theory of equations. Now we are going to study further complicated upgrade equations and understand the concept. Okay. Let us see here. Complex roots occur in conjugate pairs for real coefficients. Suppose this is an equation. I have a complex root of a plus ib. A plus ib, a root for this. So what is the sum of the roots? And sum of the roots is minus b by a, so 3. So it does not have any imaginary part. That means what? When I add in the sum, the imaginary part should get cancelled. So if there is a plus ib is a root of this, then there must be a minus ib also a root of this. Then only a plus ib plus a minus ib get cancelled. 2a is a real part of the complex number. So they always occur in conjugate pairs. That's what we call it as conjugate pairs. Suppose the same thing can be seen in different ways. Suppose a complex number is a root. So I put complex number here in place of x. So c to the power of n plus c to the power of n minus 1 like n. So this is 0. It is having two components, real component and imaginary component. Both are 0. Real is 0 and imaginary is 0. It does not matter whether imaginary is plus or minus. If it is minus also is 0. Plus also is 0. Minus of I into something or plus of I into something is 0 is 0. So that means minus also is automatically a root of this. So the conjugate is also a root of this. Suppose if n is odd. So there are odd figures. So then all conjugate pairs occur in pairs. So we have even roots are covered with this. So odd means there must be one real root. There must be one real root. If all are conjugate roots, so I should have even roots, but n is odd, so it has only odd roots, so one must be real root. So to avoid the conjugate root for the odd number. So suppose you see a quadratic equation, we have minus b plus or minus root of b square plus 4ac by 2a. So if this is minus, so we have a complex number, so it is having both plus and minus. So if one root is plus, there must be a minus root. If b, a, b, c are real coefficients, then I should have a both plus root and minus. Same thing is applicable for n degree. Same thing is applicable for n degree. So this is for complex. Now let us take irrational roots. Suppose root 2, root 3, root 4 are irrational roots. Say surds, alpha plus root b. So if such roots are there and the coefficients are fractions, quotients, then what is the sum of the roots? You have some real plus some surd, but the real sum of the roots is 3 here minus b by a. So the surd should get cancelled. That means alpha minus root b also should be a root of this. If alpha plus root b is a root, that means there must be alpha minus root b also a root, because the sum should tally with a real number. Same thing like conjugate is also applicable. So both equations, whether it is a real complex number or it is a surd, you should have, they always come in pairs. Always come in pairs. Let us see. Now we have to find a polynomial equation whose roots are 1 plus I minus 1 plus I. What is 1 plus I conjugate? Is 1 minus I. 1 plus I is having a conjugate of 1 minus I. What is minus 1 plus I conjugate? Minus 1 minus I. So minus 1 plus I. There are 4 roots here. There are 4 roots here. So the equation is equal to this. Then two equations with roots 1 plus I and 1 minus I. One plus I and 1 minus I. So this is the equation. So what is the sum of the roots? I get cancelled, 2. So minus BA. What is the product of 1 square minus I square is 2. So this is one equation with these two equations, and with these two roots, this is another equation. I am simply multiplying both the equations. So it's a quadratic multiplication, so I can do easily. So finally what I am getting, x to the power 4 plus 4 is equal to 0. This can be written as x square plus 2 whole square is x square plus 2 plus 2x minus 2x, a plus b into a minus b, a plus b whole square minus b square, a square minus b square. So I am getting this equation, which is having roots of. So suppose if this equation is given, we have to solve. X to the power 4 plus 4 is equal to 0 and find the roots, reverse of this. So we cannot say x to the power 4 is equal to minus 4. So x square is equal to 2i plus r minus 2i, and x is equal to root of plus r minus 2i. No. So we have to add here plus 4x square minus 4x square and convert into two such equations and come back to these four roots. Because extra 4 has four roots. Root of minus I, root of minus 1 is I, but root of minus I does not have any value. So I square is having value, but root of minus I is not having any value. So this has to be converted by plus 4x square minus 4x square and convert into two equations and equate them to 0 so that we will get. Okay. This is the way it has to be solved. Now, let us say another problem. Roots are given. So plus 4 root 3 means there must be a root of minus 4 root 3. 5 plus 2i means there must be a root of 5 minus 2i because real coefficients are real. So when I with these 4 roots, so I have two quadratic equations with suppose 5 plus 2i minus b by a, sum of the roots. Sum of the roots. This is the product of the roots. 5 plus 2i into 5 minus 2i. So 5 square minus 4i square. That means 29. This is 29. Second one is 4 root 3 into minus 4 root 3. 4 4s are 16, 3s are 48 minus. So the product of sum is 0. Here sum is 0. So we have two quadratic equations by this one set of two roots, this is another set of two roots, and we simply multiply it. So find one of the root is given, find the other roots. So minus I plus root 5 is given. So root 5 minus I is 1. Quadratic equation, one root. So root 5 plus I also will be root. So root 5 plus I. Since root 5 is there, minus root 5 also is root. So minus I minus root 5, I minus root 5. I plus root 5 is root means I minus root 5 is also root. So that we have 4 roots. From one root, we got 4 roots. How we got 4 roots? The root 5 minus I, it should have root 5 plus I. Root 5 minus I should have root 5 plus I. Since root 5 is there, I should have minus root 5 also. I minus root 5 and minus I minus root 5. So once I got 4 equations, you can solve the problem. Now let us say, here one root is given. So automatically 2 plus 3i, root 3i is one root. That means the second root is 2 minus 3i. So what is the equation between these two roots? Having these two roots, x square minus sum of the roots is 4x plus product of the roots 4 minus 3i square. So 4 plus 3, 7. So I am dividing this extra 4 equation with this equation. We know this division, earlier we have done. First I put x square. So I am tallying with extra 4. X square into x square, extra 4. X square into minus 4 is minus 4x cubed plus 7x. When I do minus from here, these two get cancelled. So these two, this becomes 4x cubed plus minus of minus is plus, then minus 11x square plus 8x plus 35. So 4x cubed. So I am multiplying with plus 4x. So it becomes 4x cubed minus 16x square plus 2. These two get minus. Then we get 5x square minus 20x plus 5. So I get multiply with 5. So that 5x square comes here. So this is 0. That means what? When I divide this with these two roots are consumed, I am left out with this equation. This is having two roots. This is minus b plus r minus root of b square minus 4ac by 2a. So minus 2 plus r minus I. So total roots are minus 2 plus r minus I. 2 plus r minus root 3i. There are the 4 roots. Let us see another problem here. So let us solve this problem. One root is given. So root 2 plus 5 is a root, means root 2 minus 5 is also root. Root 2 also you have said plus r minus root 2 and plus r minus root 5. There are 4 roots here. I have totally 5 roots needed. I have 4 roots. So with these two roots, I made two quadratic equations. So when I multiplied, I got this equation. So 4 minus 14x square plus 9. So with this equation, if I take 3x out here, x to the power of 4 minus 14x square minus x to the 4 minus 14x square. This is 9. I've taken 3x, so this is 9. So 27x will become 9. So between these three terms, if I take x out, x to the 4 minus 14x square plus 9. Again, these three terms I take 4 out, x to the 4 minus 14x square plus 9. So this is common term. This is what we got from these four roots. So 3x minus 4 is another root. So x is equal to 4 by 3 is the fifth root. Understood? How to? Otherwise, you can divide. You can divide this equation by this equation by this division method. But since it is easily seen, x to the 5, x to the 4, there has to be 3x. This is a gap between them. So 3x I have taken out. So automatically, by observing itself, I can solve the fifth root. Okay. Let us understand transformation of equations. Transformation of equations. Let us say f of x is this one. K into x minus x1 into x minus x2, there are n roots. So what is f of minus x? So my x, wherever x is there, I'm putting minus x. So I take out minus outside, becomes x plus x1, x plus x2, x plus x1. What are the roots of this? X plus x1 is 0, that x is minus x1. The roots are minus of the roots of this. Here roots are x1, x2, x3. Here roots are minus x1, minus x2, minus x3. So we want to get an equation of negative roots. I have to put in place of x minus x. Okay, so because I have taken out minus 1 common, so minus 1 to the power of n into x plus x1, x plus x2, x plus. Okay, now, so this is multiplication form, this is expansion form. So in place of x, I am putting minus x, minus x. So I have taken out minus 1 to the power of n. So then I am getting alternatively plus minus. First is plus, because minus 1 to the power of n I have taken out. So a0 into x to the power of n. Minus is gone out. Then n minus 1. So 1 minus appears here. So alternatively plus minus will come. Alternatively plus minus will come. That means f of x, f of minus x has come into picture. The signs of alternate terms vary for f of minus x. Suppose in place of x I put x by k. In place of x I put x by k. So x by k minus x1 into x by k minus x2 into x by k minus x3. If I do LCM, x minus kx1, x minus kx2, x minus kx3 like that by divided k to the power of n. What is the root of this? X is equal to kx1 is the root, kx2 is the root, kx3 is the root. If x is kx1, this becomes 0. That means f of x is 0. If x is kx3, this becomes 0. F of x is 0. So roots have been multiplied by k term. So whenever I want an equation of roots multiplied by k term, I have to use x by k. In place of x, I have to replace by x by k. Similarly, if I want roots of division by k, x by k, roots are to be divided by k, x1 by k, x2 by k, then they have to be multiplied by k, xk. It is replaced with kx. It is to be replaced with kx. So kx minus x1. So x is equal to x1 by k. So roots are divisible by k. So let us see another one. Suppose this is the f of x, general form. X minus 1 and x minus 2 and x minus, these are the roots. A is the leading coefficient. So what is x of x minus h? So in place of x, I am putting x minus h. So x minus x plus h, x2 plus h, x3 plus h. So what have become? Roots have become x1 plus h, x2 plus h. The roots have x1 plus h, x2 plus h, x3 plus h. So I have f of x minus h. So if I want roots plus h, plus 4, plus 5, plus 6 of the roots of this, then I have to put f of x minus a. In the other point, if I want minus of roots, I want x plus a. This is called transformation of roots. So I can transform the root here. You see here, a simple f of x is equal to 3. Let us say x is equal to 3. How we write it as x is equal to 3? We write as x minus 3 is equal to 0. Now I have added plus 13 here. I have added f of x plus 13. So x minus 3 plus 13 is equal to 0. That is equal to x plus 10 is equal to 0. X is equal to minus 10. So this is x is equal to minus 10. So the equation x is equal to 3 is transferred to x is equal to minus 10 by adding plus 30. H is equal to 30. So by addition x plus 30. So this is translated by minus 13. Hence you add minus 30. The root is translated by minus towards the x-axis, plus towards the positive x-axis, minus to negative x-axis. So by it is translated by minus 30 means x minus 3 plus 30. When it comes to here, when it comes to left hand side, it becomes plus 30. Like that here. X minus h will have a root of x plus h. X plus h will have a root of x minus h. Okay, the alternate. So this is a simple transformation of root from here transferred to negative side. So we have to transfer minus 13 means we have to add to the equation plus 30. Let us do. Here we have seen f of x is this. Now what is f of 1 by x? So wherever x is there, I am putting 1 by x. So when I take x to the common, a by x to the power of n into 1 minus xx1, 1 minus xx2, 1 minus, what are the roots of this? X is equal to 1 by x1, 1 by x2. So the roots are inverse, reciprocal of this root. Here roots are x1, x2, x3. Here roots are x1, x2, x3, 1 by. So here the equation for having a reciprocal roots is x2. Suppose if I multiply this with x to the power of n, so x to the power of n, x to the power of n get cancelled. So I get a into, this is the equation. This is having roots of reversal roots, reciprocal roots. So when I multiply f of x with x to the power of n into f of 1 by x, I'll get roots of 1 by x roots. Understood this? Okay. If x1 is root of fx1, then x1 square is root of f of root x. Suppose f of x is there, I am putting root of x. So wherever x is there, I am putting root x. So what is the root of this here? If I put x is x1 square, the root of x1 square is x1. x1 minus x1 is 0. So plus or minus x1, but I am taking plus x1. So 0. So root of x is equal to x1, x is equal to x1 square. So here we are getting roots, squares of the original roots. I'll get if I replace with x with root x. Slightly opposite. Here we have plus kx minus kx. Plus into kx divided by kx to get other roots. Similarly, here we have root x for x square roots. So minus x we have already seen. F of x, f of minus x is alternate. This is minus x. Minus 1 whole to the power of n, x plus x1 into x plus x2. This we have seen earlier also. This is minus x. Minus I have taken out. I get all positive terms. So when I multiply these two, f of x into f of minus x into minus 1 to the power of n. So what happens? Minus 1 to the power of n into minus 1 to the power of n becomes minus 1 to the power of 2n, which is always positive. So we remove this term. So we are multiplying all plus x minus x1, x plus x1, x minus x2, x plus x2, like that. So if I multiply these two, what will become? X square minus x1 square, x square minus x2 square, x square minus xn square. This is the equation. So now I am replacing x square by x. What I am doing is replacing x square by x. So x minus x2 square, x minus x2 square, x minus x1 square. Here what are the roots here? X2 square is the root, x2 square is the root, xn square is the root. So this gx is having roots of squares of the roots of f of x. Same thing here. The roots both are same. F of root of x. We substitute, either we can substitute f of root of x, or we can do this way. This is one method to get squares of the roots. And the other method is you multiply fx with f of minus x into minus 1 to the power of n. We get roots of that equation is, and we replace x square by x. So gx is replacing x square by x in f of x, f of minus x into minus 1 to the power of n. We'll get the roots of squares of roots of f of x. This way also, you simply put root x because root x is slightly complicated. Suppose if the x cube is there, root x means x to the power of 3 by 2. We may not be able to solve it. So it is easy to have this method. Now let us see here. F of x we have, f of minus x we have, is alternative plus and minus. Here we have seen factorization method. We are seeing expanding method. This is expanding method. Now I am multiplying these three. F of x, f of minus x into minus 1 to the power of x. So we get two equations. This is f of x. This is minus alternate plus minus is f of minus x. So when I am multiplying these two, so if I put all plus as f1x, a0 x to the power of n plus a2 x to the power of n minus 2. If I put f1 is a0 x to the power of n, a2 x to the power of n minus 2, all positive terms as f1, all negative terms as f2. So f1 plus f2x into f1 minus f2x, that is f1 square minus f2 square. So this is f1x, this is a general form of f1x, this is a general form of f2. This we need not by heart, but understand that this can be converted into two forms, a plus b into a minus b. This is all a plus b, this is a minus b. All minus put together, a minus b. All plus put together, a plus b, which is f1 and f2. So this way we can transform, we can get the other roots. We'll do some exercise so that we understand this concept. So I want roots of 2 times of roots of this. We know we have to put 2 times root means I have to put x by 2, x by k. So in place of x, I am putting x by 2 to the power of 5, x by 2 to the power of 4, x by 2 cube. Wherever x is there, I put x by 2. So when I simplify it, what I am getting? This is my equation having roots of 2 times roots of this. What is the reciprocal roots of this? I want reciprocal roots. So we have just seen x to the power of n into f of 1 by x. X to the power of n into f of 1 by x is the reciprocal. This is the reciprocal. We get reciprocal roots. In place of x, we are putting 1 by x. So x to the power of n multiplication is required to remove this denominator. So I put x to the power of 5 into 1 by x to the power of 5 plus 11 by x to the power of 4. Wherever x is there, I am putting 1 by x. So by rearranging the terms, I am getting 6 x to the power of 5 minus 13 x to the power of 4 plus 4x cubed plus x square plus 11x plus 1. This is simply a reversal. Reciprocal in nothing but x to the power of 5 coefficient will go here, numerical coefficient will come here. It is simply a reversal. You see here, x to the power of 5 1, so this is 1. 6, this is 6 to the power of 5. 11, this is 11. This is 3, x cubed is 3, this is 4x. So like that they exchange, the coefficient get exchange. We get reciprocal roots. Now I want squares of roots of this. I want squares of roots of this. So one way is I can substitute f of root x is 0. So x to the power of 3 by 2 plus 3x minus 7 root x plus 6 is equal to 0. So this is what 2 by 2 get cancelled. So this becomes x to the power of 3 by 2 minus 7 root x is equal to, this is 3x. So 3x plus 6 I am taking other side. So I am again squaring. So x to the power of 3 by 2 plus 2 is 4 by 2, that is 2. I am getting x square. So this is the equation which is having squares of the root. Or I can do this method, f of x, f of minus x into minus 1 to the power of 1. Also I will get squares of the roots. But it is by simply, I just simply submitted root x. Now you see another equation. Roots are cube roots of this. So in place of x, I am putting x to the power of 1 by 3. I put x to the power of 1 by 3. So this becomes x. This becomes x to the power of 2 by 3. 3 into x to the power of 2 by 3 plus 2. So x plus 2 is equal to minus 3 into x to the power of 2 by 3. Now I am cubing both sides. So a plus b whole cube is equal to 3 minus 27 into x square. So when rearrange terms, I get this equation which is having cube. So cube of roots of this equation. So square of roots, I am putting root x. Cube of roots, it's 1 by 3. So we have to like that, we have to proceed. Suppose translate by -2 of the equation. We have to translate by -2. So -2 means when it comes to the equation to this side, x -2 comes to the other side of equation, it becomes f of x plus 2. So wherever x is there, I have to put x plus 2. These are the x plus 2 terms. So when I expand it, I am getting a final equation. This is slightly cumbersome process. So I have to do to the power of 4 to cube. Then I have to rearrange the terms. And so there is an easy method suggested for such things. When you translate by 2, we do divide it repeatedly by 2. See, this we have taken 1, -5, 7, -17, 11. We have divided by translation by -2. So I am putting here plus 2. Putting here plus 2. So when I divide, I am getting this equation and a reminder. So this is A4 coefficient. When again dividing by 2, I am getting another remainder A3, and dividing by 2, I am getting A2. This is A1 and A0. So x to the power of 4 plus 3x cube plus x square minus 17x minus 19 is equal to 0. So this is the same what we got here by expanding. X to the power of 4, 3, 1, minus 17, minus 19. X to the power of 4, 3, 1, minus 17. So in place of cumbersome of expansion, this is the method given to get easily the coefficients. A0 is x to the power of 4 coefficient, A1x cube, A2x square, A3x, A4 numerical. So this is the formula. Qx is equal to x minus h into q k1 plus x into x. X minus h into q k1 plus x. Just come somewhere. See here it has come. F of x is a0 and x of n, a1 x of n minus 1 an. Now f of x plus h, I want x plus h. Where is x plus h? It's not here. Okay. Let us understand this concept. This is how this derivation is used in this concept. Each next term is divisible by x minus h. Here h is the x minus h is h. So translation by 2 minus 2 means divided by 2. Here again roots are to be translated by plus 2 of roots this. Plus 2, they have to translate it by plus 2. That means I have to replace f of x minus 2. So wherever x is there, I have to put x minus 2. Is x minus 4 has come? No, this is x minus 2. This is x minus 2 whole cube. 10 into x minus 2. This is wrongly written. So I am replacing by plus 2 here. This is okay. So how I am going to do it? I am going to do it in the second method. So plus 2, it is to be translated by plus 2. So I have to divide it by minus 2. Here translation by minus 2 divided by plus 2. Here translation by plus 2. I have to do minus 2. So when I do the coefficients of given equation, 1, minus 1, minus 10, 4. 1, minus 1, minus 10, 4, 24. So When I do repeated divisions by -2, I'm getting A40, A30, A220, A1, A01. So x to the power of 4 minus 9x cubed plus 20x square is equal to 0. X to the power of 4 minus 9x cubed plus 20x square is equal to 0. Okay, this is the if I translate this by -2, I'm getting this equation. So x square into this. So what are the roots here? Here is this root is 5 4s are 20, 4 and 5 are root here. So 0, 4, 5 are roots. This has roots of -2, -2, 2, 3. F of x has roots of -2, -2, -2, 2, 3 is f of x. Now, by translating by +2, I am having an equation with roots of 0, 4, 5. If you see here, -2 plus 2, 0. -2 plus 2, 0. 2 plus 2, 4. 3 plus 2, 5. So, roots are transferred by +2. The roots are transferred by +2. That is why f of x minus 2. Here, make coefficient of x square 0 by method of transforming. This is the given equation x square. So what is the formula for making it 0 in the process of transforming? X plus h, I want the h. So it is the transformation is given by minus ak by n a0. Ak is whichever term I have to make it 0, that coefficient. N is the degree of the equation, a0 is the leading coefficient. So here ak is -6, degree is 3, and coefficient of x is 1. So minus of -6 by 3 into 1. So this is 2. I have to translate by 2. So x minus 2. I have to put x minus 2. So when I do see here, first lesson, we have to translation by -2. That means we have put x plus 2. So by -2, I have to put here 2 as the divisor to get the coefficients. H, I have to divide it by h to get the coefficients. Here also, it is to be translated by x minus 2 plus 2. So I divide by -2 here to get the coefficients. So translation -2, I divided by 2. Translation +2, I have to divide it by -2. So translation -2 means what? X plus 2. I have to substitute x plus 2 here. This is what I have substituted here, x plus 2, x plus 2. Why? Because I have to translate by -2. Shifted to left hand side. So this is the equation which you have taken another process. So here I have to translate by +2 means I have put x minus 2. So I have divided by -2. We see same thing here. Make coefficient of x square 0. So I have taken minus already here. Minus ak by n a0. That is 2. So I have to divide it by 2. So when divided by 2, I am getting a0 is 1, a1 as 0, a2 as -2, a3 as 1. So the equation is x cubed minus 2x plus 1 is equal to 0. So this is the equation. But here you see x square term becomes 0. This is what is asked. You want x square coefficient should be 0. X square coefficient became 0. How it became 0? When I am selecting the transformation by ak by n a0. So ak is -6, n is 3, a0 is 1. So I am getting 2 here. So when I am dividing by 2, I am getting x is equal to 2. X minus 2, x is equal to 2. So when dividing by x minus 2, this factor, I am getting the coefficients. Similarly here, make coefficient of x cubed. Here I want to make x cubed coefficient 0 by adding some h. So to find out that is again minus ak by na0. Ak is 4, n is 4, a0 is 1. 4 by 4, that is minus 1. So I am dividing it by minus 1. So what I am getting? This is a a4 coefficient, a3, a2, a1. So this is the equation. X raw 4 minus 4x square plus 1 is equal to 0. So this is how we make coefficients 0, by using this minus ak by na0 and directly taking it here. Because this is already minus taken here, so there is no opposite side. Same factor will be divided. It will be in fact x plus 1. This will be in fact x minus 2. This is x plus 1. Like, okay. Let us see this. Reciprocal of an equation. Reciprocal of an equation. If the coefficients are oppositely symmetric, if ak is a minus an minus k, an minus k is ak, then we call this reciprocal. For example, 2x cubed, 2 here, 5x square, 5. The coefficients are alternate. All are plus. All are plus. Coefficient are alternate. This is called class 1 type reciprocal, odd degree. So minus 1 is root of this equation. Because this becomes minus 2 plus 5 minus 5 plus 2, it becomes 0. So for a class 1 type of reciprocal where all are positive and a odd degree, we have minus 1 is a root. Here also you see, these are negative terms. Here 2 minus 2, 5 minus 5. Again odd degree. In this case, plus 1 is the root. So 2 plus 5 minus 5 minus 2. So here plus 1 is a root. Here minus 1 is a root. Here plus 1 is a root. Because of the symmetry. Again, in fact, they get cancelled. These 2 terms get cancelled. These 3 terms get cancelled like that. Suppose if there is an even degree, it is an odd degree, they get equally cancelled out. 2 terms plus, 2 terms minus. But here even degree, you have a central term. So 1 and 1 minus 1 need not be a factor for this reciprocal. This is also reciprocal, 6 and 6, 35, 35, 62. But it is an even degree and this need not be 0. So you have to solve separate. Here we have to group them with x square. We have to group them. X raw 4 and 6, we have to divide by x square and we have to group them. We'll see in the example. Here the root cannot be assumed. If you see are even of class 2 type, plus, minus, plus, minus, plus, minus. These are class 1 type. Class 1 means what? Sign is same. Class 2 means sign are opposite. Class 2 type reciprocal without central term. Here we don't have central term. X raw 6, x raw 5, x raw 4. There is no x cubed here. X square, x 6. So in this case, both plus 1 and minus 1 are roots. If I put plus 1 also, it is becoming 0. It is becoming minus 1 also, it is. If central term is there, it need not be set. Okay. Now this is a. So let us do, and this concept let us understand in this process. So we have given an even degree with a central term. You have even degree with a central term. So plus 1 minus 1 need not be 0. So I am grouping. I am dividing entire by x square. So x raw 4 by x square is x square plus 1 by x square minus 10 into x cubed by x square is x plus 10 by x square is by x plus 26. You see now it is simple quadratic. I can put x plus 1 by x as y. So x square plus 1 by x square become y square minus 2. So I can solve the equation with y. I got 2 values of y, 4 and 6. When I substitute y, x plus 1 by x is equal to y, I am getting total 4 roots. 2 plus or minus root 3, 3 plus or minus 2 root 2. There are 4 roots for this equation of a reciprocal type with central term, even central term. Now let us see, this is odd term. Odd term 1 and 1. Minus 12, same sign, class 1 type, first type. So definitely first type is, we know minus 1 is the root. So I am dividing it by minus 1. So when dividing by minus 1, I am getting 2 minus 1 minus 11 minus 1, 2 is 0. So 2x to the power 4 minus x cubed minus 11x square minus 1x plus 2 is equal to 0. Now we know this has become a even degree with a central term. So again I have to use this process to solve this equation. So I am dividing by x square. 2 into x square plus 1 by x square minus 1 into x plus 1 by x minus 11. So same time, if I solve it, I am getting these 4 roots. These are the 4 roots I am getting in this process. So if it is simple type, minus 1 is the root. So x to the power 5 I reduced x to the power 4 root, and x to the power 4 is converted into y, equation of y, and solve the problem. So we should use whatever methods in hand so that we can solve what the problem is given. We have to first find out whether it is reciprocal or not. See, this is a reciprocal. Even if you divide with 1 also, here how much I am getting? Here also I am getting a reciprocal. So here I use x square as common out. What I have explained here to be group after dividing with x square and solve.